Hi guys, you're welcome to my channel. So today we want to look at another topic from the revision section we have been having on JAMB. So if you're a JAMBite or WAEC student, you need to pay attention to what we are doing here currently because it's going to help you to prepare as fast as possible. Now, the topic we are looking at today is a very simple topic, but what examiner wants to test under this topic is very, very tricky. And you just need to understand those things, and that's motion. Now, what are the things you should know as far as this topic is concerned? Number one is to understand the definition of it. So when they say the definition of motion, it's all about the change in position in respect of time. So sometimes examiner might want to lead these things or relate it with relative motion. So as we have currently, we are told that the earth is moving, but you and I we can disagree. Why? Because we are inside the earth, we are not seeing it moving. However, somebody that is in the space looking at the earth will see the earth moving. Just like you are in your daddy's car. When you are in your daddy's car, you're sitting beside him and your dad is driving. Obviously, to you and your dad, nobody is moving. But to somebody observing you from outside, you guys are moving. So you need to understand this and relate it down to velocity. So when you have a uniform velocity is as the same thing as a body that is static. So when a body is moving with a uniform velocity, it's more or less as if the body is not moving. Understand this very well, because sometimes you are going to be given some calculation that you need this particular understanding to make your U or your V to be 0. Do you understand this now? So let's quickly dive into it. So another thing you should understand, aside from what I just made mention of in the definition now, is the types of motion. When you talk about the types of motion, we have the translational motion. The translational motion. This translational is also referred to as rectilinear. When I say a motion is translational, what it simply means is that that motion occur in the direction that they want it to occur. It's not necessarily like a straight line, because most times when I say translational or rectilinear, what we usually think of is a straight line. It can be straight, it might not be straight. Am I making sense? But whenever a body moves in a specified direction, that body is said to be performing what? A translational motion. For example, if I have a ball, this is a football now. If I kick this football, the ball is said to go in the direction where I kicked it. Do you understand where I'm coming from now? Let's say I'm targeting a pole here. So if I kick it here, it's coming to this pole. Although it might not move straight down to this place. And it might move straight down to that, but it's going in that what? Direction. That simply means it's moving as a translational motion. The wheel of your car, when you are driving, if you turn it to the right, it goes to the right. If you turn it to the left, it goes to the left, right? So that's translational. Am I making sense now? So any motion that goes in a specified direction, that motion is said to be translational. Why am I breaking it down in this manner? I'm breaking it down in this manner so that you can understand when a question is coming to test your in-depth knowledge. Instead of that brief definition. No, don't just go by the brief definition that they tell you that, oh, the movement of a car from Lagos to Kano, from the movement of a man from one place to another. You have to understand it deeply. That's when you can answer JAMB questions that has to do with it. I hope you get this. Alright, so that's what you need to understand. When I say translational motion, a motion in a specified direction, either straight or not straight. So long it's going in that direction that you ask it to go, that motion is said to be what? Translational. So you can give me more example in the comment section if you have the time. So the second one is rotational. Rotational motion. So when you say that a motion is a rotational motion, what does it mean? What it means is that when a body is moving in a rotating manner about a fixed point, that is, this is a fixed point now, and a body is moving around this continuously, non-stop, continuously, just like your ceiling fan. You know, anything that makes your ceiling fan to leave that fixed point, something is about to happen. It's either you get injured or you break your head. One of the two will happen. Why? Because what? If the ceiling fan is there, it will just continue moving around in that fixed position. That is rotational. When you look at the steering of your car, it's in that fixed point and you rotate it differently, but it's still in that same fixed position. The same thing to the wheel of your car. The wheel of your car remains in that fixed position and is rotating. That's rotational motion. I know somebody's about to confuse now that with one side example that the wheel of a car is translational. Why is it rotational again? We'll talk about that later, but just understand this now. So you can see it's rotating about that fixed point, right? Not only that, if you look at your ball has a center. You know, when we want to play ball and we just want to know the people that will pass first, or we always use our hand to cover the VAP place, isn't it? That VAP place is a center. When you kick your football, by the time you kick your football, that place will keep rotating about that fixed point. Do you understand? So that means a ball, when you kick a ball, that ball is performing a rotational motion at its center. You need to understand all this because these are tricky ways or a way of JAMB asking you question under this particular place. So you have to understand that. So aside from rotational motion, we have random motion. And when you talk about random motion, you are talking about a motion that is irregular. So don't make a mistake and think that random means circle. No, random does not mean circle. Random means that something you cannot predict, unpredictable. You can't predict it. So you cannot say it's going to go to left now or it's going to go to right. So anything that behaves that way, any motion that behaves randomly like that you cannot predict that this direction or that motion is random motion. For example, if I dash a paper in air, if that paper is moving, you cannot say maybe it's coming down straight or it's going to go like this now. What is going to determine how much is going to move haphazardly is the numbers of air that is available. Do you understand where I'm coming from? The same thing goes to the smoke particles. When they are burning bush and the smoke is going up, it's random. The same thing when you spray PEF or you spray insecticide in your house, all of those things, that is what random motion. Now, examiner can now want to they might want to ask you about the test of Brownian motion. So random motion is like an evidence that molecules does exist. Examiner can extend their question to that level. Do you understand where I'm coming from now? So take note of that. So another one that you need to know of is oscillatory motion. This oscillatory motion can also be called vibratory motion. Now, when I say a motion is vibratory or oscillation, or oscillatory rather, it's a kind of motion that also have to do with a to and fro movement in a fixed position. In what? A fixed position. So there are some objects that they are performing this to and fro movement without you knowing. For example, the second hand of your clock. When you're using wristwatch, I'm not talking about digital one, analog. You know, you have 3 hands. The second hand, the way it's counting. Are you getting this now? If you have done a simple harmonic motion, which I'm still going to be talking about, you are going to understand. I think I proved I proved how that second hand is what is oscillating in one of my lectures. I might drop the link in the description part of this video. You can watch that so that you get to understand. That hand is what is performing an oscillatory motion. As well, the skin of a talking drum, when you are drumming, that skin of a talking drum, before it can bring up sound, it has to vibrate. That vibration is what is bringing about sound. That means the skin of the talking drum is also performing what? Is performing an oscillatory motion. A punching bag. So when something moves to and fro, you said that it's performing an oscillatory motion, or what you can refer to as vibratory motion. I hope you understand that now. So then we have what we call mixed motion. And this is where JAMB usually tests you the most under the mixed motion. When I say mixed motion, that is body that are performing more than one type of motion. For example, the clock that we talk about. When you ask me, or if you ask about the entire kind of motion that the clock is performing, you say it's performing rotational motion, rotational and oscillatory. But in most cases, examiner only come with just oscillatory. But if you see rotational and oscillatory in the option, this is better for you to pick than picking what? Oscillatory. Am I making sense? So the same thing goes to the wheel of a car. It's also performing two types of motion. Am I making sense now? It's performing translational and rotational. That's what I mean. That's what I mean by what? Mixed motion. The same thing goes to the ball. The ball. The complete motion of the ball that you kick is what? Is translational and rotational. However, some people might want to like, oh, ball is performing a projectile motion. That is another type of kick. There's difference between those kind of kick. Do you understand? If I kick a ball to go horizontally, it's not what? It's not performing a projectile motion. But if I kick a ball to go like this, that's what? Projectile. So you have to know the difference between the two now. So most times, examiner will use the wheel of a wheelbarrow instead of the wheel of a car. However, just understand that anything wheel performs what? Two types of motion, translational and rotational. And if they don't want to use the word translational, they can use the word rectilinear. Do you understand that now? Alright, so if you understand this now, another thing that examiner might want to test you on under this topic is to know the causes of motion. When you talk about the causes of motion, you talk about force. Force is the causes of motion. That is force. And when I say force, is a vector quantity. We've talked about that before. It's a vector quantity that's when you apply it to an object, it sets the object in motion. There won't be motion if there is no force. Are you getting this now? So we now have different type of force. We have like force. This is called push. And we have unlike force. Unlike force. This is called pull. But you see these two types of forces that we talk about, they are example of contact force. Both like force, which is push, or like force, which is pull, they are both example of contact force. Then we have frictional force. Frictional force, which we are still going to discuss later, and this is the kind of force that you can as well divide into two, in solid and also in fluid. So in fluid, it is called viscosity. In fluid, friction in fluid is called viscosity. So these are type of forces that we have, and we have what we call force field. Force field. So under the force field, you have electric field. You have electric field. You have gravitational field. And you have the magnetic field. So all these are what examiner might wants to know about force and calculation about it. So we're going to talk about calculation on force when we are talking about other things that they want to test under this particular topic. I hope you understand now. So now, when forces causes motion, I think I need to divide the board now so that we structure things. When forces causes motion, there are a couple of things that the examiner wants to ask you about the body, about the motion of the body. Something like the velocity of the body, the acceleration of the body, and the distance that the body covered, as well as the time that takes the body to do all of those things. Am I making sense? So we have the following equation for equation of motion. We have that V is equal to U plus AT. We have that S equal UT plus half AT square. We have V square equal U square plus 2AS. These are the equations of motion. Now, what do you need to understand about these equations? All you need to understand about this equation is that for you to know the right equation to use on every question, you must know and understand the parameters given to you. Am I making sense? But before I start discussing that, let me discuss some certain things that can become zero in this equation. It's possible for you to have your V to be zero, but you have to know when it can be zero. When can your V equals to zero? You want to know when can V equal to zero. Your V, which is final velocity V, can be zero when a body is retarding. Retardation will set your V to become what? Zero. When I say retardation is the same thing as deceleration. When a body is decelerating, final velocity is what? Zero. And you get to know that a body is decelerating. For example, if you apply brake to a car. When you apply brake to a car, at that point, that car will retard before it can stop. So final velocity will be zero. Do you understand that now? So you need to understand this because question would not tell you, but you have to know. So let's say a driver applied a brake to a car. So when it applied brakes to a car, that velocity there, final velocity becomes what? Zero. Do you understand where I'm coming from now? So where can your U, which is initial velocity, be zero? Your initial velocity can be zero when a body starts from rest. When you hear that a body starts from rest, that means your initial velocity is what? Zero. What it simply means is that the body did not stop until it gets to its destination. Do you understand where I'm coming from? The body maintains that same velocity till it what? Gets to its destination. And that's why U will become what? Zero. Do you understand where I'm coming from? Alright? So when can your acceleration become zero? Your acceleration will be zero if and only the body is moving with a uniform velocity. When a body moves with a uniform velocity, your acceleration will be zero. Why? Because acceleration is the change in velocity. So if you are told that acceleration of the body is 2 meters per second squared, what it means is that the velocity of that body is increasing by 2 every seconds. What do I mean? Let's say I have the velocity of the body to be 2 meters per second. So in the next 1 second, the velocity will have become what? It will have become 4. In the next 1 second, it will become what? 6. In the next 1 second, it will become what? 8. That means the velocity is increasing by 2. And if the velocity is increasing by 2 every second, that means the acceleration is this. So if the velocity is now uniform, what it means is that the velocity is the same. It's not increasing, it's not decreasing. Since it's not increasing or decreasing, the measure of increase or decrease is going to be what? Zero. That's when your acceleration can be zero. And when can your distance be zero? Your distance will be zero when the body is in the same position. Do you understand that now? Okay, so that's the case of equating anything to zero in this equation. Now, for you to know the proper equation to use for any question, when you are reading the question, do well to write out the parameters given. When you write out the parameters given, that lets you know the suitable equation to use. Am I making sense? Lastly, before I go in this particular area, let's talk about this time. There is a way examiner wants you to what? Miss something else. And I'm going to cite a very good example on this time. Whenever you are given a time in form of position, maybe the question says in the second seconds, or they said in the third second, or they said in the fourth second, or sixth seconds, as the case may be. If you look at all these statements, they are like position. Don't make the mistake of taking time to be 3 when it is third seconds. It's not the same thing as 3 seconds. When it is second seconds, it's not the same thing as second 2 seconds. When it is fourth seconds, it's not the same thing as 4 seconds. When it is 6 seconds, it's not the same thing as 6 seconds. And the list goes on. You have to note that. Now, what does it mean whenever time is given in form of position? Whenever examiner gives you time in form of position, what they are asking you is what happened in the last 1 second. For example, if the examiner says in the third seconds, what it means is that what happened between 3 seconds and 2 seconds. If they say in the 4th seconds, what happened within 4 seconds and then 3 seconds. If they say 6 seconds, what happened within 6 seconds and 5 seconds. I hope you understand that. So whenever you have a question like this, how do you solve it? I'm going to show you how to solve it in a very kind of literal way that is expected of you as a WAEC student, and I'm going to solve it in a smart way that is expected of you as a JAMB or even as a WAEC student that is smart. So, and I believe you are smart. So let's look into that. Let me give you a question to quickly tackle that. Let's say a body, or let me say a car starts from rest. A car starts from rest and move with a uniform acceleration. Let me say 2 meters per second square. I see it now. What is the distance covered? What is the distance covered in the 3rd seconds? Have you seen the question now? The question states what? A car starts from rest and move with a uniform acceleration 2 meters per second square. What is the distance covered in the 3rd second? How do we go about that? So obviously you all start with solution. So if you look at this question now, they said a car starts from rest, and I told you earlier, when the body starts from rest, initial velocity becomes what? 0, all right? And moves with a uniform acceleration of 2 meters per second square. Acceleration is 2 meters per second square. What is the distance covered in the 3rd seconds? The time is 3rd seconds, right? All right? And we are looking for distance. So we have S, we have U, we have A, we have T. Then we are looking for S rather. We have U, we have A, we have T. So which equation are we going to use? Like that, guys? Thank you. Very simple. We make use of this equation. S equal UT plus half 8E squared. That's how you get to know the equation to use. So we are looking for S. Remember, when the time is 3rd seconds, it means the distance covered in the last 1 second. So we have to calculate what happened, what distance covered in 3 seconds and what distance covered in 2 seconds. That's how we go about it. So we have this to be S equal, what's our U? Our U, S is equal to, what's our U? That's 0. So I'm going to put 0 here into bracket. Our T is what? 3 seconds now. We are calculating for 3 seconds now. Plus 1 over 2A. A is 2. Then multiply by 3 squared. Alright? So S equal, this is going to be 0. This 2 will cancel this 2. So S is equal to 9 meters. Right? So at 3 seconds, the body covered a distance of 9 meters. So what happened at 2 seconds? So we calculate for that. S equal is 0 into 2 plus 1 over 2 times 2 into 2 squared, right? So S equal 4. Abi? So the distance covered in the 3rd seconds will now be S3 minus S2. That is the distance at 3 seconds and the distance at 2 seconds. So that will now be 9 minus 4, right? And that will give us the distance at 3rd seconds to be 5 meters. I hope you understand this now. But let's say as a JAMB, how should you solve this? You don't need to stress yourself. Just say S equal UT plus half AT squared. Are you seeing it now? So this one becomes 0, right? Because this is 0. So you have that S equal 1 over 2 times 2 into bracket 3 squared minus 2 squared. This and this you cancel. S equal what? 5 meters. And you're just done. So there's no need of you wasting much of your time And that's how to go about it. So whenever you see a question like this, you solve it like this. And sometimes examiner can be so easy, and they will tell you that what is the distance. They can tell you that, okay, it can start from rest and move with a uniform acceleration 2 meters per second square. What is the distance covered in the last 1 second? Are you getting it now? So they can say, okay, at 10 seconds, what is the distance covered in the last 1 second? Or at 3 seconds, what is the distance covered in the last 1 second? So you just know that you apply the same word, the same process, and you get your answer with ease. I hope you understand this now. So this is the second thing that examiner wants to look at under this topic as far as equation of motion is concerned. So I hope you understand this now. So what's the next thing you now need to understand under this topic? And that is what? The laws of motion. So I'm going to continue from there in the next video. I hope you understand this now. So I'm going to drop the link to complete lecture under this particular topic. I'll drop it in the description part of the video. So if there's anything you want to get more, especially questions under this, I saw a lot of questions in that video, so you can check, and I wish you success in your exam. See you on the next one.